Okay, so this question asks to find the integral of cosine to the fifth theta, sine to the fourth theta, d theta. Okay, let's write it down. Cosine to the fifth theta, sine to the fourth theta, d theta. So we can write this as cosine 4 theta times cosine theta times sine to the 4 theta, d theta. And we're gonna put u as sine theta. The only reason that we're putting u as sine theta because cosine theta is alone and sine theta is even number. So u is sine theta, and then du is cosine theta, d theta. And then this will become then u to the fourth, and then this becomes du, and then we have cosine to the fourth theta. If you remember your trig identities, cosine squared theta plus sine squared theta is equal to 1. Cosine squared theta is 1 minus sine squared theta. So cosine to the fourth power is same as 1 minus sine squared theta squared. And we put sine theta as u, so 1 minus u squared squared. So this is just u to the fourth times 1 minus u squared to the square du. Let's do some calculation. This is u to the fourth, 1 minus 2u squared plus u to the fourth power du. So this becomes u to the fourth minus 2u 6 to the sixth power plus u to the eighth power. And then it's du, right? So this becomes u to the fifth power over 5 minus 2u 7 to the 7 over 7 plus u 9 over 9, right? And then constancy, don't forget that. So we have that, and since we originally put u as sine theta, this becomes sine theta to the fifth power over 5 minus 2 sine to the 7, minus 2 sine theta to the 7th power plus over 7 plus sine theta to 9th power over 9 plus c. Okay, what is our answer? So sine to the 5th power, okay, so it's not a and e, it's negative 2 over 7, so it's gonna be b. So the answer for this question is b. Okay, so this question asks to find the integral from 0 to pi over 3 tangent cube x secant squared x dx. Okay, let's write it down. 0 to pi over 3 tangent cube x secant squared x dx. Since we see secant squared x dx and we know the tangent x derivative is secant squared x, we're going to put u as tangent x and du will be secant squared x dx, right? So this can be written as u to the cube du, u to the cube du. Okay, and then we have to write the bounds again. So u1 is tangent 0, which is 0, u2 tangent pi over 3, which is square root of 3. So it's from 0 to square root of 3. So if you integrate this, this is u to the fourth power over 4 from 0 to pi over 3. This becomes square root of 3 to the fourth power over 4 minus 0 over 4, which is 0, so we don't have to worry about it. So this becomes just 3 times 3 over 4, which is 9 over 4. So the answer for this question is A. Okay, this question has to find the appropriate trig substitution and express that integral of 1 over square root of 4 plus x squared dx in terms of x. Okay, so integral of 1 over square root of 4 plus x squared dx. And if you remember it, a squared plus x squared, you can write it as x equals a tangent theta. In our case, we have 4 plus x squared, meaning a squared is 4, so a is 2. So our x becomes 2 tangent theta. If you look at our answer choices, that's only gonna be A, C, and E. So not D and B, okay? Cool. So we have x equals 2 tangent theta. Let's find dx. dx is 2 secant squared theta d theta. And you can write the entire integral in terms of theta then. So 1 over dx. dx is 2 secant squared theta d theta over 4 plus x squared, which is x is 2 tangent theta, so 4 tangent squared theta. You can group it 2 secant squared theta d theta. You can group it the square root of 4 plus 4 tangent squared theta as 4 1 plus tangent squared theta, right? So square root of 4 is just like 2, so it can come out of the square root, right? 2 secant squared theta d theta over 2 square root of 1 plus tangent squared theta. And if you remember your trig identities, 1 plus tangent squared theta is same as secant squared theta. So this just becomes 2 secant squared theta d theta over 2 square root of secant squared theta. Square root and square cancels out, and 2 cancels out. So this becomes secant squared theta over secant theta d theta. And secant squared and secant can be cancelled out, so it's going to be just secant theta d theta. And let's look at our hint. Secant theta d theta is just ln secant theta plus tangent theta plus c, right? Okay, so we know x is equal to 2 tangent theta, right? Because eventually we have to write everything in terms of x. So if you divide this by 2, this becomes x over 2 equals tangent theta. So let's draw it then. Okay, so tangent, this is theta, this is 2, this is x squared plus 4. Okay, so secant theta is 1 over cosine theta, right? So let's find cosine theta. Cosine theta is here, square root of x squared plus 4 in the denominator, 2 over square root of x squared plus 4. So this is that, and then secant theta is 1 over cosine theta, so this just becomes square root of x squared plus 4 over 2. And tangent theta is, we already found, which is x over 2. So this is just ln square root of x squared plus 4 over 2 plus x over 2 plus c. So this is equal to option number E. So the answer for this question is E. Okay, so this question asks to find the value of a definite integral from 0 to 2 x cubed over x square root of 4 minus x squared dx. Let's write it. 0 to 2 x cubed square root of 4 minus x squared dx. If you remember your trig substitution, a squared minus x squared is x equals a sine theta. In our case, it's 4 minus x squared. So a squared is 4, so a is 2. So this just becomes x equals 2 sine theta. Okay. And then our dx would be just 2 cosine theta d theta. And let's find our new bound. So x is x is 2 sine theta, right? Meaning x over 2 is sine theta, you just divide it by 2. And then sine inverse of x over 2 is theta, right? Because you do the inverse on both sides, and sine inverse and sine cancels out, and theta is left alone. The only reason that we are doing this is we're going to write everything in terms of theta instead of x, which is why we want to change the bounds value of x into theta bounds. So sine inverse of 0 over 2 is just 0. Cool. Sine inverse of 2 over 2 is sine inverse of 1, which is pi over 2. Okay, we know everything, so we can write this thing in terms of theta. So this is just going to be 0 to pi over 2, and x is 2 sine theta, so 2 sine theta cubed over square root of 4 minus 4 sine squared theta dx is 2 cosine theta d theta. Okay, so this is 0 to pi over 2, 8 sine cubed theta over, group them by 4 in here, 4, 1 minus sine squared theta, 2 cosine theta d theta. Same thing, 0 to pi over 2, 8 sine cubed theta, square root of 4 can come out as 2, because square root of 4 is just 2. So 2 square root of 1 minus sine squared theta. Sorry, 2 cosine theta d theta. 2 cancels out. And if you remember your trig identities, sine squared theta plus cosine squared theta is 1. So cosine squared theta is 1 minus sine squared theta. So this can be written as 0 to pi over 2, 8 sine cubed theta over, this is gonna be cosine squared theta times cosine theta d theta. So 0 to pi over 2, 8 sine cubed theta over cosine squared, and square root cancels out, so this is just going to be cosine theta times cosine theta d theta. Cosine theta is cancelled out. Cool. So this is 0 to pi over 2, 8 sine cubed theta d theta. And this is 0 to pi over 2, 8 sine squared theta and sine theta. We can write this like this, right? Okay, and then if you remember your trig identity, which we use in here, sine squared theta is same as 1 minus cosine squared theta, right? So this becomes 0 to pi over 2, 8, 1 minus cosine squared theta times sine theta d theta. Okay, and if you put u as cosine theta, du will be negative sine theta d theta, which can be covered in here. So this is gonna be just 8, 1 minus u squared minus du, right? Because we are doing minus du because we want sine theta d theta, not negative sine theta d theta. So I'll just write it here. Okay, negative du is same as sine theta d theta. And we can change this part into just negative du. Cool, and we have to find another bounds. Too much bounds finding, right? u1 is cosine 0, which is 1. And u2 cosine pi over 2, which is 1. Wait, what am I doing? Cosine pi over 2 is 0. My bad. So negative, and if you have a negative sign and if you want to change your bounds, what you do is cancel the negative sign and change the bound. So this is just gonna be 0 to 1, 8, 1 minus u squared du. I'll write it in here. It's kind of everywhere, sorry. 0 to 1, 8 minus 8 u squared du, 8 u minus 8 u to the 3 over 3, from 0 to 1, 8 minus 8 over 3, and then it's gonna be just 0, so it's just plus 0, so nothing. So this is just 24 minus 8 over 3, which is 16 over 3. So the answer for this question is C. Okay, so this question has to find the proper form of pressure fraction decomposition. Okay, we love this question. Okay, let's look at the denominator because we don't really care about the denominator part, so just look at the denominator. Okay, let's write it. X squared minus 2x minus 3, x squared minus 2x plus 1, x squared plus 2x plus 5. Okay, x squared minus 2x minus 3 can be written as x minus 3, x plus 1, right? And x squared minus 2x plus 1 is just x minus 1 squared, right? And this cannot be separated, so x squared plus 2x plus 5. Okay, we have that, and let's write it then. So we have the first term as x minus 3, so denominator x minus 3, and it's constant a. So what the important part of the partial fraction decomposition is when you choose your denominator, you follow the power of denominator. So in this case it's x minus 3, so it's the first power, right? So on the denominator it's gonna be 1 less of the denominator power, meaning it's gonna be 1 minus 1, so x0, which x0 is just constant, right? Which is why we just only put a constant on top of it. Same thing, x plus 1 is the first order, and then the denominator will be constant number because it has to be the 0 power. So it's gonna be b. And the tricky part of the squared things are you use the same power as your first repeated terms. So meaning it's x minus 1, right? X minus 1 is same logic, d, some kind of constant. Oh, sorry, c, some kind of constant. And then you have x minus 1 squared, and some people might think it's x minus 1 squared, so you're gonna put something like dx plus e, but that's not it. Since it's repeated term, we're gonna follow the same power slash constant, I guess. So x minus 1 squared has to use the same power as the first repeated term power, meaning it's gonna be considered as the first power. I don't know why we consider like that, but that's the rule. So you just kind of have to remember it. So if it's repeating term, you have to use the repeated term's power. So it's gonna be considered as first power because x minus 1 is first power, meaning our denominator will be just constant. Like, oh, why am I keep going forward? D. Yeah, it's not E. Sorry. And then we have x squared plus 2x plus 5. X squared plus 2x plus 5. So it's square value, meaning the denominator, nominator has to be one less of the denominator power, meaning it's gonna be the first order, right? So it's gonna be ex plus some kind of constant f. So if you look at this option, that's gonna be equal to option E. So the answer for this question is E. Okay, so this question asks to compute the value of the definite integral from 0 to 1 over x squared plus 5x plus 6. This is same as 0 to 1 over x plus 3, x plus 2, right? It's just you just separate those x squared plus 5x plus 6 into x plus 3 and x plus 2. And if you look at this form, what should you do? Partial fraction decomposition. So we are going to put 1 over x plus 3, x plus 2 is equal to x plus 3. It's the first term linear on the denominator, so the denominator will be zeroth power, so it's going to be just some kind of number constant. And then I'm just going to erase this part. X plus 2 is also linear, meaning the denominator power will be 0 power, so it's going to be some kind of constant b. Let's write that. And then if you multiply x plus 3, x plus 2 on both sides, this just becomes 1 over a x plus 2 plus b x plus 3. Plug in numbers, x equals -2, which is 1 equals, this is going to be 0, plus b. So b is 1, cool. X equals -3, plug it in, 1 equals -a plus 0. So a becomes -1. Cool. So this 1 over x plus 3, x plus 2 is just 1 over x plus 3 plus 1 over x plus 2, right? And this is entire thing, dx, 0 to 1. So let's separate it. -1 over x plus 3 dx, 0 to 1, plus 0 to 1, 1 over x plus 2 dx. So if you remember your natural log, 1 over x derivative integral is, sorry, not derivative, 1 over x integral is just ln absolute value of x, right? So this thing is just -ln x plus 3 from 0 to 1 plus ln x plus 2 from 0 to 1. Plug in the numbers, -ln 4 plus ln 3 plus ln 3 minus ln 2. Okay, so this is 2 ln 3, right? 2 ln 3. Yeah, if you notice that I took it out the absolute value because 3 absolute value is just 3, so you don't have to put any more absolute value sign anymore. So this thing becomes 2 ln 3 and we're left with -ln 4 plus, minus ln 2. If you remember your natural log, I guess, rules, -ln 4 is -ln 2 squared, right? And this 2 power can come out down here. So basically, this negative ln 2 squared is negative 2 ln 2. So this is the same thing as negative ln 4. So this is negative 2 ln 2 plus 2 ln 3 minus ln 2. This becomes 2 ln 3 minus 3 ln 2. So the answer for this question is A. Okay, this question asks which of the following improper integrals converge. Let's look at it. The first option. A is 1 over x dx, negative 1 to 1. Okay, so ln x 1 to negative 1, right? 1 over x, and integrating is ln x absolute value. So this becomes ln 1 minus ln negative 1. ln 1 is 0, and negative ln minus 1 is just undefined, right? So 0 plus something undefined is just undefined, so this is diverging. I'm just going to move it down here, diverge. This is not it. So all those option 1 is gone. Cool. And then option B, 0 to 1, 1 over cubic root x dx, which can be written as 0 to 1 x negative 1 over 3 dx. Okay, and you can integrate this, right? X 3 over 2, and then this is gonna be 2 over 3, and this is gonna be 3 over 2, sorry. And integrating from 0 to 1, so this becomes 3 over 2 minus 0. So this is just 3 over 2. So this one actually converge, right? So this is 2 works. And then let's look at option 3. 0 to infinity x e to the negative x squared dx. We see x squared and x, so we're going to use, what's that called? U substitution. So u is equal to x squared, du becomes 2x dx, and we just want x dx, so x dx divided by 2 on both sides, so du over 2. Okay, so this thing becomes du over 2 e to the negative u 0 is 0. I will write it again. u1 is 0, so it's going to be 0. u2 is infinity. Infinity squared is just infinity, so it's infinity. So it's going to be 0 to infinity. Integrating, so 1 over 2 can come out. 0 to infinity e to the negative u du. So it's 1 over 2 negative e to the minus u. 0 to infinity, 1 over 2 negative e minus infinity plus e0, which is this thing comes 0, e0 is 1, so this is 1 over 2. So this one converge. So converge, third one works. So 2 and 3. So the answer for this question is C. Okay, so this question asks to find the arc length of the curve y equals 2 over 3x to the 3 over 2 power. Cool. So the arc length function is x is equal to some kind of interval 0 to 3, and then square root. So I'll just write the general equation first for the arc length. S is equal to some kind of interval from a to b, square root of so this thing is just 1 plus, and then you find the derivative of fx, so f prime x dx. So in our case, our fx is 2 over 3 x 3 over 2, so f prime x is just gonna be 2 over 3 times 3 over 2 cancels out, x 1/2, right? Because we are subtracting 1, right? So this is just x 1/2. Oh, and then you have to square it. Sorry, I forgot the square part. Yes, you have to square the derivative. So if you squared our derivative, this becomes just x. So in our case, our arc length is from 0 to 3, 1 square root of 1 plus x dx. And if you remember your, no, you don't have to remember anything, sorry. This is from 0 to 3, 1 plus x 1/2 dx, right? So if you integrate this, this is going to be 1 plus x, 3 over 2, and then 2 over 3, 0 to 3, from 0 to 3. Plug in the numbers. This becomes 2 over 3, 4, 3 over 2, and then minus 2 over 3 times 1 to the 3 over 2, which is just 2 over 3. So this is 2 over 3 times 2 squared, 3 over 2, 2 cancels out, and then this is just 2 over 3 times 8, 2 to the 3 power, so it's 8 minus 2 over 3. So this is 14 over 3. So the answer for this question is D. Okay, so this question asks to find what the area of the surface using the curve. Okay, the surface area equation is 2 pi. If you're rotating around the y-axis, it's gonna be x, and then integral of square root of 1 plus f prime x squared dx. Okay, so if it's like x-axis, this is gonna be y in here, and it's gonna be dy in here. Yeah, so in case you're interested, I guess. Yeah, but in our case, it's gonna be y-axis rotating, so it's gonna be x and dx. So 2 pi x, and integral is from 0 to 1. Let's find our f prime. Fx is 2 minus x squared. F prime x is negative 2x. F prime x squared is 4x squared. Negative 2x to the squared is 4x squared. So this is square root of 1 plus 4x squared dx. So this thing is equal to option D. So the answer for this question is D. Okay, so this question asks to find the centroid of the center of mass for the x coordinate. Okay, and we are given y is equal to negative 2x plus x, 2x plus 3. So let's find the area first. Area is negative 2x plus 3 dx. Oh, you might be curious why that equation comes out like that. So it's gonna be 3 over 2, 3. Let's draw it then. Draw that, and then it's gonna be y equals 0 here, x equals 0 here, and x equals 1 bounded. So the area is this area, and this area is only bounded by y equals negative 2x plus 3. There's no, I mean, there is a gx, but gx is just 0, so it's not like important to subtract. So a is equal to negative 2x plus 3 dx, integrating from 0 to 1, right? So this is just negative x squared plus 3x, 0 to 1, negative 1 plus 3, which is 2. The only reason that we are finding the area because we want to find the coordinate of the center of mass. And x coordinate can be found as 1 over a, 0, some kind of interval a, b, x, and then fy minus g of y, and then dx. In our case, this is going to be negative 2x plus 3. So our centroid equation is 1 over a, which is 2. Yeah, because a is 2, so which is 1 over 2. And then integrating from 0 to 1, x, fy minus gy is just negative 2x plus 3, negative 2x plus 3 dx. 1 over 2, 0 to 1, negative 2x squared plus 3x dx. So this becomes 1 over 2, negative x cubed over 3, and then there should be 2. So negative 2x cubed over 3 plus 3x squared over 2, 0 to 1. So this becomes 1 over 2, negative 2 over 3 plus 3 over 2, and then plus 0 is nothing, so nothing. So this is just negative 1 over 3 plus 3 over 4. So this is negative 4 over 12 plus 9 over 12. So this is 5 over 12. So the answer for this question is A. Okay, so this question asks to determine which of the following sequences are convergent or divergent. Let's look at the option 1. One is an is equal to 2n over 3n plus 1. If limit of n goes to infinity, 2n over 3n plus 1, this one will be substantially like so small that it's not as important in calculation. So this thing is just 2n over 3n and can be cancelled out, so it's going to be 2 over 3. So this is actually convergent. So A is convergent. Okay, not B and D then. So A, C, E are convergent. I said A is convergent, meaning option number 1 is convergent. Sorry, I just got so used to saying option 1 is A. So yeah. So option number 2 is an is cosine n pi. So cosine infinity pi, right? Because if the limit of n goes to infinity of an, this is just going to be oscillating from -1 to 1. So it doesn't, oh wait, I wrote it the backward. Sorry, -1 to 1. So it's just going to be oscillating from -1 to 1. So it doesn't converge to any value. So option number 2 is not convergent. This is just going to be cosine infinity, which cosine infinity is just looking like this. So it's not converging any value. So it's going to be divergent. So I guess this is just going to be E or C. Okay. Option number 3 is an equals n sine 1 over m. If you put limit of n goes to infinity, n sine 1 over n, this is just going to be going to infinity. So we have to use our friend L'Hopital. Yay. L'Hopital. And I'm going to write limit n goes to infinity, sine 1 over n as the denominator, and I'm going to write 1 over n as the denominator to make it look similar. So if you do the L'Hopital rule, I'm just going to write it here in L'Hopital instead, L'Hopital, then this thing becomes cosine 1 over n and -1 over n squared because of the chain rule, and this is going to be -1 over n squared as well, right? So -1 over n squared is actually cancels out. So this is just going to be cosine 1 over n, and if n goes to infinity, this is just going to be 1 over infinity, which is cosine 0, which is 1. So the value actually exists, so this is convergent. So the answer for this question is C. Okay, so this question asks to compute n equals 1 to infinity 2n minus 1 minus 3n plus 1 over 4n. Let's write it. N equals 1 to infinity 2n minus 1 minus 3n plus 1 over 4n. Let's separate this into 2. So it's going to be n equals 1 to infinity 2n minus 1 over 4n minus 3n plus 1 over 4n. So I want to make it into geometric series form, so I'm going to separate this into n equals 1 to infinity 2n times 2 negative 1 over 4n. If you remember, 2 negative 1 is just same as 1 over 2. This can be written as n equals 1 to infinity 1 over 2 2n over 4n, which can be written as n equals 1 infinity 1 over 2 can come out because it's just constant, so it can come out of the series. So it can come out as sigma form. That's what I was trying to say. 1 over 2, n equals 1 to infinity, and this can be grouped as 2 over 4 to the nth power. Okay, let's do the other side. Negative in a sigma -3 to the nth power times -3 to the first power. This is the same thing as that. I just separated out so I can just use -3n and 4n, and it's under just 4n. So the same logic, -3 is constant, so it will come out of the sigma, and so sigma -3n oh yeah, negative 3n over 4n, and negative negative, so it's gonna be just plus 3. Sigma negative 3 over 4 can be grouped as to the nth power. So if you look at this thing, this value of r is less than 1, so you can use the geometric series. So this is geometric series is s to the infinity a over 1 minus r, where a is our first term and r is our rate, which is inside of n. So in our case, I'm just going to put it as s1 and s2. Let's do s1 first, which s1 does not include 1 over 2, just a sigma per. Okay? So s1 is equal to a over 1 minus r. In our case, our a is 2 over 4 to the first power, which is 1 over 2, right? I mean, it's 2 over 4, but if you just reduce it, it's going to be 1 over 2. So 2 over 4, I'll just write it for simplicity, sorry. So first term is 2 over 4, and then over 1 minus, the rate is 2 over 4 as well, so 1 minus 2 over 4. So this is 2 over 4 over 2 over 4, this is just 1. So this value becomes 1 over 2. And then our s2 value, let's write it, is a over 1 minus r. So negative 3 to the 4, negative 3 over 4 to the first power, which is just negative 3 over 4. And then 1 minus 3 over 4, because this is our rate. So negative 3 over 4 over 1 plus 3 over 4. So negative 3 over 4 over 7 over 4, which is negative 3 over 7. And we have 3 in front of it. So 3 times negative 3 over 7 becomes negative 9 over 7. So this entire thing becomes negative 9 over 7. And we got the first term is 1 over 2, and the second term is negative 9 over 7. So this is just going to be 1 over 2 minus 9 over 7. So this is 14. 7 minus 18, so negative 11 over 14, which is option C. So this answer for this question is C.